All right. So let's keep cooking. We're getting ready to write some more code here. We did a problem at the end of class last time to kind of remind us the problem we're trying to solve. But let's just do one more of these just to kind of get warmed up today. So let's convert another number. Now remember what we're going to do this by hand. We're trying to create a computer program that automates this, that we can give different inputs to, and it works regardless of the input we give to it. And what we're trying to do is we're trying to convert from a decimal number to some other base, whether it's hexadecimal, whether it's base 22, whether it's base 8, base 2, whatever it is. So let's do an example with binary then. So let's hide this. Did I say hide? There we go. So let's do 172 from decimal to binary. All right, everybody take 2 minutes. Try to by hand convert 172 from decimal to binary. Remember, this is our pattern where you're going to divide by 2 over and over again, recording the remainder, either 0 or 1. Keep going until you finally end up with a 0. Read your answer from bottom up. All right, so let's take a look at this. So we start off, we write out the 172. That's our starting point. We're going to divide this by 2. That gives us an 86. 86 times 2 is 172, so we have a remainder of 0. Then we're going to take 86. We're going to divide that by 2. That gives us a 43. 43 times 2 is 86, so we have a remainder of 0. 43 divided by 2 is 21. 21 times 2 is 42. So we have a remainder of 1 to get us to the 43. Record the remainder. 21 divided by 2 is 10. 10 times 2 is 20, so we have a remainder of 1 to get us to 21. 10 divided by 2 is 5. 5 times 2 is 10. Remainder of 0. 5 divided by 2 is 2. 2 times 2 is 4 with a remainder of 1. 2 divided by 2. 2 goes into 2 one time. 1 times 2 is 2 with a remainder of 0. And then 1 divided by 2. 2 goes into 1 0 times. That's our endpoint. That 0, we want a red flag should be going off. 0 times 2 is 0 with a remainder of 1. We then read our answer from bottom up. So this is 1 0 1 0 1 1 0 0. That's the binary equivalent of that. For our program, we want this guy to be represented as a string. So we're kind of doing the inverse of what we already wrote. We already wrote some code that we give it our starting value. We called it initial value, I think, as a string. And we said, I want this in decimal. And then it did the whole thing. This is the ones place, 2s, 4s, 8s, or whatever base we're working with. It summed it all up. We've been working on that. Now we want to do the reverse, where our result is a string, and we ultimately want our starting point to be that number that decimal number. So what we should have when we're all said and done is if we call this function and then call that other function we already wrote on it, we're back to our original. Should just reverse each other. Okay. So we want to capture this process generically. That's what programming is. Remember, we go back to the beginning. I said, why is programming hard? Because we're really good at solving problems. We have trouble articulating how we solve them. Okay, so that's what we're trying to do here. We just solved this problem. Now we want to be able to articulate exactly the details of how the step-by-step approach to how we did it and translate that into memory, asking questions, repetition, the thing that every single programming language gives us. All right, good.
So for the person we're trying to find the like remainders to get our values, just kind of going back to the hexadecimal slide. I don't know if they have that now, but
Right here.
Yeah. So how did we get 13 as our remainder?
So when I do 2989 divided by 16, I get 186. If I take 186 and I multiply it by 16, I get 2976. 2976 needs an extra 13 to get me to 2989. That's what's left over from that integer division. So really, we're going, what we're doing here when we talk about remainders, we're going back to third grade math, long division. Remember, it would have been written as 2989, and then there would have been that little this guy.
You rounded down, right?
There's no rounding involved.
Or the divide 2989.
I truncate it.
Yeah.
I just cut all the decimal point off because it's the whole number result. So do we remember? Well, I say, do we remember this from third grade? Well, actually, you should, because I remember it from third grade. And I think I had third grade a couple minutes before any of you did. So remember that long division thingy where you went through and in the end, we had a answer. In this particular case, our answer is 2976. Remainder 13. Remember that guy? So 2989 divided by 16, we write the 2976 down here. Click. Then we subtract those, given our final answer, which is 13, which then goes up here to the remainder. All right, so this is long division from a long time ago. Effectively, we have two different kinds of divisions when we're talking about computer programming. We have integer division. That is, we have the whole part of the division, and then we have what's left over, the remainder. So integer division would say, don't use any decimal point stuff. All right, so we got two parts to our answer, the whole value and the remainder. Or we can have floating point division, where 5 divided by 2 is 2.5 to give us that instead of 2 remainder 1. All right, so we are trying to write this generically. So let's jump into our program here. And let me open up. I'm lost. Where's is it? Here? That guy? Okay, there we go. All right. So we're going to start writing a function here. We're going to call it define, and we're going to call this guy decimal to base. All right. That's the function we're going to write here. And it's going to take in an initial value and the base we want to convert it to. And we can even put a little comment in here. We're trying to, add a little bit to our programming practice. So just so we can keep all of our functions separate, maybe I'll put a little comment before this and we'll say initial value is the decimal version and base is the base we want to convert it to, something like that. So a little note right before the function just kind of tells us what we're about to try to accomplish. So as we're looking through here, it could be a reminder. So these guys, when you put a little pound sign beforehand, that treats it as a comment, not something it tries to run the code on. If you come from C, C++, Java, C#, it would have been that, 2 front slashes.
Trying to convert the decimal value, but it's to.
We're trying to do this decimal value to another base.
Oh, to
To any base. Decimal value to another base. So if we were to call this function with this slide, we would say 172 is what we pass in for initial value, and 2 is the base we want to convert it to. For this slide, we would call that same function, we would pass in 2989 as the initial value, and the base for hexadecimal is what?
16.
16. So we pass in 16 for the base and expect it to give us a string. In this case, we want it to give us the string BAD. And in this case, we wanted to give us the string 10101100. Should be the result. All right. So now we're going to capture this process. So we have our initial value, this guy right here. We have our base. Those are 2 inputs that are passed into our function that we're about to write. What do we now do? Well, we're going to take our current value and we're going to divide it by our base. And we're going to get our new current value. We're whittling it down to 0, right? Isn't that what's happening over here? A 172 became an 86, became a 43, became a 21, became a 10, a 5, a 2, a 1. Finally, it becomes a 0, and that tells us we're done. This is the last time through our loop. We're going to stop repeating ourselves, and in the end, we're finally going to return our answer. So now we have to think about how we're going to be building up our answer. So we're going to be learning a couple of new things today. All right. So we're inside of our function. I'm just going to press enter a couple of times here. Just to get us kind of a clean looking screen, even though the other stuff is still there. Programming languages don't care about zillions of spaces. We can always close the gap later on. I just want to have our focus on just what we're working on. All right. So we are going to do something multiple times. So we're going to create a loop. We have multiple kinds of loops. The loop we're going to use now, which is the loop we've already been introduced to, is a while loop. Okay. We want to keep doing something. We want to keep dividing by our base over and over and over again until our value is finally whittled down to a 0. Okay? So we're going to say while initial value is not equal to 0. Or we can say while it's greater than 0. Either one of those will accomplish it. Both of those guys, from our perspective, say the same thing, right? We know it's going to be non-zero when we first call it. Presumably, we're going to pass it something that's non-zero. And we want to keep going as long as it's either not a 0 or as long as it's greater than 0. Both of those Boolean expressions effectively express the same thing, right? Keep doing this until it becomes a 0 or it's almost a 0. All right. Now, what are we going to do? Well, we want to do some division stuff. All right, so we're going to take our, here, let's just we'll create a variable here called temp. We're going to temporarily remember something. So we'll just create a little helper variable here. So we're going to say temp is equal to whatever our initial value is divided by base. All right, now, and actually, I think I can use, I'm going to, what question did you just ask?
Are we trying to get the remainder?
Well, yeah, we are. I'm showing it. This could be the decimal version. So I'm about to show the new thing. So I think we can do the Jupyter Google Colab thing here. Go to this. Oh, wait, that's not. Give, but no. All right, so let's just write some code here so we can kind of experiment with this. So let's assume that our initial value, can I make this bigger? Is that big enough? All right, so if I say my initial value is, and what do we have on our slide? 172. All right, so we're going to put that in here as 172. And let's experiment with this a little bit. We know our base is equal to 2. Now, if I were to print 172 divided by 2, we get, oh, bad example. Let's just change it just a little bit to give us the answer I wanted to give us. Okay, so we see we get a decimal point value, right? So we take 171, and let me change this to initial value, just so we're using variables here. And we'll change this to base. All right, so if we run this guy, our initial value is 171 in my little example here. Base is 2, 171. 2 does not go into 171 an even number of times, right? But our answer here has a decimal point value. We don't want that. All right. We want the version of division. I mentioned a few minutes ago, we kind of have two versions of division. We have integer division, and then we have floating point division. Default division with a single slash is decimal default division. That's what division really is, right? But we're going back to third grade, which actually is modulus arithmetic is what we're learning here. Is actually some of our most powerful algorithms are based on this. All right, so what I'm going to do here is we're going to put a double slash. Now, I usually like putting some spaces in here, so I'll do that. Now we get that 85. All right, so it truncated the 0.5 off. It didn't do any rounding. It just said, I don't know how to hold decimal point values. But
does it always round down?
It's not rounding. Think of it as taking whatever your number is, and we take a sword and we just cut anything from the decimal point after off.
Okay.
So if it's 0.99999, it's just gone.
So it does the same as floor?
It'll do the same as floor. Floor does that. You'll likely never use it, but the alternative to floor is seal. Goes up to the next one. Go ahead.
But, to find the remainder, will we have to go through the process of subtracting it, or can we just use the modulus operator?
Well, yeah, so that's the next question, right? So now we need to come up with our remainder. So you've heard me verbalize how we figure out our remainder previously, right? So we know in this particular case, since we're dividing by 2, the only possible remainders we can have are 0 or 1, right? If we had a remainder of 2, that means we did bad division because it went in another time. Make sense? Okay, so our possible remainders when we're dealing with base 2 are 0 or 1. Our possible remainders when we're dealing with base 8 is 0 through 7, things like that. So we know the question we should be asking right now is, okay, how do I get the 1? I have the whole number part of it with all decimal point stuff cut off, but now I need that 1 part of it because I'm going to need that as part of my program. So now let's do this the way that I've been verbalizing it. All right. So I've been saying, I'm going to put this into we're going to call this whole number is equal to that guy. All right, so we're going to create another, we're going to remember something else. And what is it going to be? It's going to be whatever our initial value is, integer divided by whatever our base is. All right, so now we want to get the remainder. And look at that. It does, I didn't know this had AI stuff built into it. Don't look at that. All right. Is there a way to turn it off? Does anybody, can you tell me how to do it like super quick?
Go to my assistance. I do all of those.
Thank you. Cool tool. I'm not saying avoid it forever. Right now, maybe just use this guy for a lot of the practice. My encouragement would probably be keep it turned off here. And if you want to have some example code or something, or you're struggling figure out how to do something, put your question into like ChatGPT and say, write me some Python that does this, so you can look at the example on there, but get used to typing it yourself in here. That's kind of going to reveal your tendencies for where you screw up. Do you not tab enough times, or do you forget the colon at the end of one of these sentences? That's just going to come with reps. All right. So we want to figure out a remainder here. Now, at this point in time, although I'm not sure, have any of the assignments introduced modulus yet? Okay, good. So at this point in time, none of you know that there's something called modulus. All right, so we're going to have to figure this out a different way. We're going to MacGyver this, right? So we're going to say, okay, well, I need to figure out my remainder, which means I need to figure out the difference between what the whole number is multiplied by my base. And then I want to subtract that from my initial value. Okay, so here's the whole number we just calculated. So in this particular case, it's 85. 85 times 2 is 170. 171 minus 170 is 1. That's a remainder. All right, then we can print this guy out. We can say we're going to print out the whole number. We're going to print out the remainder. Go ahead and run this guy. So there's our 85 with a remainder of 1. All right, makes some sense? All right. So, in fact, actually, let's just keep doing it in here, and then we'll move it over to the other thing. All right, fun enough. Now let's look at the another way of doing this. So we're going to say remainder 2 is equal to initial value mod base. We'll print out remainder 2. So there's our alternative way of getting the remainder. So let's throw this on a slide. Call this guy integer division. All right, so double slash, no spaces between them, is the integer division quotient operator, gives you the whole number part. Percent symbol is the modulo operator, which gives you the remainder of an integer division. So we have two different symbols, one that lets us get the whole number part, one that lets us get the remainder part. And this guy's called modulo or mod. Sometimes some languages spell it out as mod. In fact, Python 2 used the word mod for doing this. Now they have the percent symbol as their mechanism for doing this, which guess what? Matches C, C++, Java, C#, Objective-C. They all use percent symbol for modulus. All right, questions about this so far? Just kind of piecing together our little ninja moves here. All right. So now we know how to get this remainder. Now, we've said we want to keep doing this division thing until this number becomes 0. So let's just do the whole thing again. So we're going to take these 3 lines. Actually, let's just work with remainder 2 now, since we now know the modulus operator. All right, so what we're going to repeat here is we're going to repeat, in this case, we'll do those 4 lines. We're going to do it again. All right, now our initial value has not changed in this case. So we're going to say up here, initial value is going to be set to something new, is going to be assigned a new value. Okay, that new value is going to be the initial value divided by base using integer division. Okay, but now we have a problem. We do want to whittle down our initial value, but when I go to calculate my remainder now, using the code I have here, I have now changed my initial value from its original form. So when I'm calculating my remainder, I'm actually calculating the next remainder, because I've lost my original value. Where if I keep it inside of our whole number thing here, I say whole number is equal to my initial value divided by base. Then we're going to say remainder is initial value there. We can print out whole number, we can print out remainder. Then what we're going to do is we're going to update initial value to be whatever whole number currently is. Get it set to the new starting point for the next time through the loop. All right. So now we're going to do the whole thing again. And let's just do it one more time after that. We'll go ahead and run this guy. And we'll see the first time we get an 85 remainder 1. The next time we get a 42 remainder 1. The next time we get a 21 remainder 0. Keep going. That'll be the 10. That'll be the 5. That'll be the 2. That'll be the 1. That should be our 0. So there. How do you make these things go away? This thing's very chatty.
I think there's another option.
Show hot cop, whatever. Oh, view, whatever. I'm sleeping. All right. So now you see all of our steps. This is the value of our initial value as it's whittled down. See, we want to keep doing that over and over and over again until it's finally a 0. So now let's just compact this. So rather than repeating these lines over and over again, if you find yourself repeating the same stuff over and over again, it probably should be living in a loop. Make some sense? So we're going to say while, geez, I got to come way up here. While initial value is not equal to 0, let's do some stuff. What are we going to do? We're going to get our whole number. We're going to get a remainder. We'll go ahead and print them out for now. Then we're going to update our initial value. And I'll go ahead and delete all this other stuff afterwards. I wonder if I just have it, that might have been it. I just have it kind of zoomed in too much. That's where it was blocking. Is this still readable? Okay. All right. So now we should see we kind of have the almost the same output. Well, we do have the same output in this particular case. All right. So we have the same output. So we've now taken all those repeats and put it into a single while loop. All right. Now, let's assume that because when we wrote this on our slides, we didn't actually care what was happening over here on the left. That was just kind of the math that was controlling everything, right? Our answer is being built up here in the remainders. Okay, so let's just portray this. And I'm going to go ahead and I'm going to stick this back to 172 so we can match these directly. So now instead of printing the whole number and the remainder, I'm just going to print the remainder. So we're just going to see those remainders. Let's go ahead and run this guy. All right, there's our remainders. 1, 1, 0, 1, 0, 1, 1, 0, 0. That's the answer we were looking for, right? Okay, so we have our remainders now. They're displaying to the screen one remainder at a time. We want to, in the end, be able to return the answer as a string. We need to build up a string. Go ahead.
I don't understand why the whole number variable is necessary. Why not just switch?
It's not. You would do the remainder first.
Yeah.
And then do the thing. Yeah. So I'm purposely putting things into extra variables so we're kind of keeping track of stuff, getting used to this, really exaggerating this idea of remembering things, asking questions, repetition. You'll come up with your own streamlined optimization, but let's keep as much stuff standing right there in front of us as possible. Go ahead. Yeah, we get some stuff there, but let's talk about that plus sign. All right, so what we want to do is we ultimately want this answer to look, let's type it here, 1 0 1 0 1 1 0 0. We wanted to get into that format. Right now we're displaying it a bunch of times. We want to get it into that format. So we need to learn how to work with strings a little bit. Go ahead.
You can just define an empty string for the loop.
Okay.
You can, like, in the loop, add, have the loop equal the remainder plus the put it at the front.
Okay, so he mentioned something called empty string.
You put and at the, you can put comma and equals empty space at the end of the print statement.
Yeah. Okay, so, but we want to build this. Remember, putting a space at the end of the thing, that's not gonna, displaying stuff to the screen is different than returning something. We are building up a value, and as soon as we're done building it, then we're going to return that value. Somebody else can decide if they actually want to display it to the screen. Okay, we're showing the steps as we're going. That's why we're printing. But ultimately, what we want to do is we want to grow an answer. All right, so let's talk about this empty string thing here. So strings are represented inside of double quotes. The empty string is a string with length 0, but it still is a string. So it is double quote, nothing, double quote. It is the equivalent if we're doing like summing a bunch of numbers, it's equivalent to starting with a 0. All right, or if you're multiplying values, it's the equivalent of starting with a 1. All right, so this is the empty string that provides the foundation that we need to build up another string. And we do that through something called concatenation. So concatenation is the act of, call it gluing strings together. Just go with that for now. Okay, so we just keep adding something onto it. So we're taking whatever it started as and we're gluing something onto the end, and now it's something new, a little bit bigger than it used to be. We have a concatenation operator, so the plus sign. All of us have seen the plus sign, right? What is the plus sign usually used for? Mathy stuff, adding stuff, right? Okay, but now it has a different use. So this is the addition operator for math. This is the concatenation operator when working with strings. So programming languages, what they'll do is when they see you use that plus sign, they're going to try to figure out, what do you want me to do? What's the instruction you're giving me? Do you want me to do mathy stuff, or do you want me to do glue strings together stuff? And it's going to determine that by looking at the values on either side of that plus sign. So in this particular case, if I were to have something like s equals hello, and S2 is equal to, what was that? Where'd that come from? Could be, they're putting it everywhere. All right. Hello world. So if I then say S3 is equal to, what is, do we know what that's coming from? Oh, it's when I whatever, S plus S2. So when I write that, what's actually happening here is it's resolving those variables. So S becomes its value, which is hello. And I know it has a lowercase h, but it's doing stuff here too. And S2 has a value of world. So the result thing here would be hello world. Except I don't want the space. That's what it would do. It would notice the things on either side of that plus sign are strings. Therefore, you're asking me to glue strings together. You're asking me to do concatenation. So we'll go ahead and glue these guys together instead of trying to do math with it. Go ahead. Yep. Empty strings become your foundation for growing a string out of nothing. So we use it as our starting point that we can start putting stuff on top of that nothingness. All right, so let's kind of see this. So I'm going to say S is equal to the empty string. Then I'm going to say S2 is equal to, well, we'll just put a H there. So now we're going to say S is equal to S plus S2. Then I'll print out S. Okay, so S was initially nothingness. If I print out S before this guy, it's going to print out nothingness. So there's my line of nothingness right here. And then I said, S, I want to redefine you. I'm going to assign a new value to S. I want it to be whatever S currently is, which started off as the empty string. But now I want you to concatenate onto yourself the H. So now we have this new string, which is the string H. That's what we just built. All right, we do this again. If I then say S is equal to S concatenated with an E, then I print out the new value of S. We're going to see we have HE. We're building this guy up. All right, so we can go and we can build up strings in our loop by just tacking on those remainders, because our final answer is built from remainders, right? All right, so let's do this in our first guess way. So I'll just come back up here to this guy. And instead of printing my remainder, in fact, we're going to still print it, but let me also get kind of an answer, a running answer going so we can kind of see what's getting built up here. So before my while loop, I want to build a variable. I'll call it answer, and I'll start it off as the empty string. It's my base for building up my result. Okay? So each time through here, I get my remainder. I'm going to go ahead and say answer is equal to answer concatenated with whatever my current remainder was.
You do it all the way around though.
Not yet. You're right. So let's not print remainder. Let's just print answer as we're going. So we just see that growing. All right. So we've added one more thing to remember here. We started off as the empty string. We're going through and we're going to just keep tacking our remainder onto it.
They have remainder as a string.
Yeah. because it won't-
Oh, thank you. So we need to do this actually. That's actually a difference between languages like C. Well, let's just start with Java because older C and C++ have a strange relationship with strings because of how old they are. But in Java, the concatenation operator can operate on as long as there's a string on one side. Okay, so let's actually add this to the notes because it is one of these little caveats. So I've mentioned over and over again that programming is the skill set, the language doesn't matter, but certain languages do have caveats. So let's just call this concatenation. Oh, yeah, caveat. In Java, plus sign is concatenation and will work on any two data types. That's probably a little bit of a stretch because any means a lot of different things, but let's just keep it loose for this because it drives the point home. So it'll work on any two data types as long as one of them is a string type. All right, so in modern compiled languages, this is pretty much a truth. As long as one of the two sides of the plus sign is a string, it'll do concatenation. In Python, plus requires both sides to be of string type. So what I was trying to do here is I was trying to take my remainder, which was a number, right? This was that, our case here, since we're working with base 2, it'll either be a 0 or a 1, but it's the number 0 or the number 1. And we're trying to take that, we're trying to concatenate that onto our running answer. And if I do that without turning it into a string, now the left side of the concatenation operator is a string, the right side is a number. Python does not know how to deal with that. And if you look at the error we get here, then I'll come to you. Can only concatenate string, not int to string. It's actually a less good error than I was expecting. Actually, it's a spelled out error. They're probably using AI to do their error. But usually what it'll say is the plus sign is not defined for string and int. Doesn't work for those two. Let me go to him and I'll come to you. Go ahead. Can I use who? Well, F strings, formatted strings, yes, but that's mostly for printing, not building. So concatenation is our tool for building up strings. F strings that you've already worked with, when you put the little F before the double quotes, that allows you to kind of print out sentences of stuff. Although you can use it for forming strings too, it wouldn't really benefit us too much here. But it allows you kind of embed your variables into the string rather than having to concatenate 50 things together to say what you want to say. Let's actually look at that here real quick because it's a good point, and then I'll come to you. So let me undo this guy. So that's why this guy needs to be a string. We have to convert it to make sure the plus sign does what we want it to do. Okay. I would call that a weakness of Python, that it can't just figure out since one side is a string. But on the flip side, converting it to a string isn't that big of a deal. In older languages, just to show you a trick here, this won't work in Python because of the exact same rule. So int to string trick. So Python has the str function. So str of 5, for example, will give you the string 5. Java doesn't require a function to, and this is true for C#, Java, C++, Swift, not Objective-C actually, but a lot of languages. So Java doesn't require a function to convert an int into a string. Instead, you can say empty string concatenated with 5 will give you the string 5. Since in Java and other languages like Java, the concatenation operator can operate as long as one of the sides is a string, you can build strings out of any of the primitive types by just concatenating it onto the empty string. And now you have a string containing only the type you had before, except now it's in string format rather than something else. Doesn't really change our problem solving, just kind of the mechanism by which we get there. It's a little different. Go ahead.
Why it does that when I'm trying to run like if statements? Like if I do a Boolean, like if a string is greater than an integer, even though the string is really an integer, it'll give me false.
But it's not really an integer. The string is really a string.
Yeah.
It might contain an int. Well, so let's just write that out. So if you say the string 5 and you're asking if that is greater than what? 2. All right. You want this to boil down to a true. Because you know as a human being that what's contained inside of that string that contains the 5 is a number. And you can look at that and say, well, 5 of course is greater than 2, so I should get a true out of this. But instead, it gives you either an error or a false, depending on exactly what you're working, which part of the program you're working with. It would actually depend, but it gives you an error because it's saying, look, I can't compare two different types of things. You're like asking, is this apple greater than this orange?
Or I think I put the equal sign.
Well, the same thing.
Yeah.
Same thing. You could ask equal sign, double equal sign, 2, something like that. You want this guy to boil down to false, is going to give you the same problem. Now we're saying, is this apple equivalent to this orange? They're not the same types, so comparing them doesn't make a whole lot of sense. You know what I'm saying? Even though a human being can look at that and say, well, obviously we got numbers there. So if somebody wrote down to a human this thing, a person could look at that and say, okay, I think what you're asking me is 5 the same number as 2? No, it's not. The answer is false. We can do that as people. Computers can't do that very well. Okay, so we need to be very precise what we're asking. So it shouldn't be surprising to us that the computer doesn't know what to tell us. It just gives us an error because we're asking it a question that at its core doesn't actually make any sense. Even though a human being at a glance can make it make sense super quickly because we're so good at solving problems. Make some sense? Okay, so let's go and we're going to print out our running answer here now that we've converted it to a string. So we see we start off with our first remainder 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, yada, 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 yada. All right, so now when all is said and done, we have all the right zeros and ones here, right? We've just built it backwards. This kind of goes back to our thing of like, well, we have to read from the bottom up to the top. Where what we've done is we've built it from the top down to the bottom. We started with the 0, then we tacked on a 0, then we tacked on a 1, then another 1, then a 0, then a 1, then a 0, then a 1. That's our final string, and it's backwards. Well, we got some options. We could go ahead and write a function that reverses a string. Not a big deal now that we know concatenation. Now, you might sit there and suspect, there's probably a reverse string function built into the language, but we can go and look it up, or we can just say, hey, I kind of know how to program a little bit now. I can write little functions. I know how to concatenate. I know how to write loops. Let's just write a function to reverse this. So here, let's write it down here as a separate thing, and then we'll call it. So if I have that string, just as a starting point, and we're going to call this initial value. Let's get the code first, then we'll pack it inside of a function. All right, and I want to see the reverse of that. We'll say reverse starts off with the empty string. Because we're going to be building this guy up. Okay, now we want to have a loop that's going to go through some number of times. All right, now let's still stick with while loops. Has the homework introduced for loops yet?
Kinda.
Well, but has it actually introduced it? I don't want to use stuff you haven't done in homework. So let's go with no. We're not getting a consensus. Let's stick with while loops for now, but know that there is another loop called a for loop that actually is more suited for this exact problem. I'll show it to you here in a second, but let's use a while loop just for the moment. So we want to say, we want to go through every single character inside my string. Now, how many characters are inside of initial value? Generically, how many characters are inside of initial value? How can I, if I give you a variable, I give you a variable and I say, how many characters in this variable, but you're not allowed to peek inside and see the thing. You have to find a way of coaxing the length of it out. Well, the number of characters is its length. The last legal character is length minus one. So, yeah, so we could say the length is equal to len of initial value. So the length is the number of times we want to go through this string. Let's just kind of print that real quick and we'll see that the length will be the number of characters that are in that string. So in this case, 5. Okay. We just know it's a bunch of characters. We happen to know it's a bunch of zeros and ones because of what we're doing here, but because we're not doing math with it yet, not the end of the world. All right. So we have the length. I want to go through my string some number of times. Now, since we're thinking about reverse, it might be handy to start at the end of the string, walk towards the beginning of the string, grabbing each character along the way and tacking it onto my new answer. All right. So let's go ahead and write a while loop that does that. So we'll say while, I'm going to say, create another variable, pause. Pause is equal to the length minus 1. Okay, like he pointed out. The length minus 1 is the last legal position inside of my string initial value. Initial value has 5 characters in it. The legal buckets are 0 to 4. Okay? Now, if I try to access bucket 5, it's going to scream at me. It's going to say, there is no bucket 5. Okay? So we're going to say while pause, I started pause off at the last legal location. What's the first legal index in a string? 0. So while pause is greater than or equal to 0.
Why do we put equal to?
Because do we want to stop at bucket 1 or we just want to stop at bucket 0? We want to actually get the whole string. If I say while it's greater than 0, we'll miss the final thing. Well, when it gets to it'll be at a 1, and this guy will stop when a 1 becomes a 0 before it processes bucket 0. So we'll leave it hanging. Let's leave it. Let's leave it and see it. All right, so understand for right now, this is a little bit off. All right. So what we're going to do is, we're going to start at the last position and we want to build up an answer. So we're going to say reverse is equal to reverse concatenated with initial value at position pause. So initially that will be this guy right here, the character 1. And the character 1 is a string type. It's treated as a string type in Python, so concatenation will work on this. All right, this is just to kind of give you this is the character 1 that lives there, as opposed to the number 1. But the character 1 in Python is considered a string type for concatenation purposes. All right, so we'll go ahead and concatenate that char1 onto the current version of reverse. And then we're going to say pause is equal to pause minus 1. we want pause to work its way towards the beginning of the string. So in this case here, it's going to start off at 4, then 3, then 2, then 1, and finally we want to actually process bucket 0 before we get out of Dodge. The way we have it right now, we're not going to quite process it. You're going to see why. So after we say pause is equal to pause minus 1, we spin back up. We ask our question again. Is pause greater than 0? So a 4 just became a 3 in our current example. Is 3 greater than 0? Yep. Grab our next character. Is 2 greater than 0? Yep. Grab our next character. Is 1 greater than 0? Yep. Grab our next character, which is the second to last character. Then the 1 becomes a 0. We spin back up. Is 0 greater than 0? It's not. So we'll skip that very last time. We won't get our right answer. So let me leave it like this. I'll fall past the while loop. So as soon as this while loop dies a natural death, as soon as pause gets down to, in this case, it'll get down to 0, and then we fall out of it, then we will print out reverse. And let's go ahead and print out the initial value as well. So we'll print out both of our answers, the first, what it was originally, and then what should be the reverse version of it. Did I call it initial value? Oh, no, no, I spelled it very funkily. Well, do we fix it? Let's fix the variable name. Initial value, and then initial value. Now man, I would have figured that would have yelled at me before then. Is just bad spelling. Okay, so now there's our two things. Here's our initial value, and here's our final result of reverse. We can see it's missing one thing. Didn't go through that very last time. We'll go up here. We'll fix our Boolean expression. We want to keep going as long as pause is greater than or equal to 0. So it does that final pass. Run this guy again. We see that we have our answer there in reverse. All right, so that's the guy we ultimately want. So what I'm going to do here is I'm going to steal this code right here. That code operates on a string called initial value, right? And reverses it. So what I can do is I can go write a function that takes in an input and call it an initial value, put this stuff as the meat of my function. And instead of printing the reverse version at the end, I'll just return the reverse version of at the end so someone else can use the reverse of it. All right. I assume this guy lets me define functions. I guess we're going to find out. So we're going to define reverse string, and this guy is going to take in an initial value. And then the meat of that will be this.
Creating another function.
Yeah. But instead of printing things at the end here, I'm going to go ahead and return reverse. And hopefully it lets me define functions and call them. All right, so now I've written a little ability. Now, this ability already is built into the language, but who cares? We wrote it ourselves, no big deal. Okay, so we wrote our own function called reverse string. I can pass any string to it, and it will give me that string backwards for whatever reason that I want to use that. It's a tool I bought at Home Depot. I can give it anything I want. It'll give me the answer in reverse. All right. So now down here, before we print our final answer, well, let's print our final answer, and then we'll say answer is equal to reverse string of answer, and then we'll print out answer again. Oop. That guy out of there. And let me kick that down, and we're still in, oh, I put that inside my loop. So we were printing along the way here, so let me steal that. All right, so now we build up our answer inside of this variable called answer. Now, punchline is we could have actually built it in reverse. We'll do that, but we didn't. We built it the wrong direction. So when we exit out of this while loop, we now have our value, initial value, in the wrong direction. So I'll go ahead. I'm sorry, we have answer in the wrong direction. So I'll print out the value of answer. Then I'll say, well, let's go ahead and use our new ability reverse string to reverse that. And then let's print it out again. Notice I'm assigning the result of reverse string back into answer. So we're overwriting answer with the reverse of itself. And then we're printing it out. So I'll go ahead and run this guy. Here is the answer we calculated before we reversed it. Here's the reverse of that answer. That's the guy we wanted. So now we probably would just stop printing that for the original answer. And now we have code that will work for any base up to base 10. Still have a little bit of a problem with things that are bigger than base 10. You got to do some conversion stuff there as well. All right, so if I change this to say, okay, I want to work with base 8, what's the base 8 version of 172? I run this again, it's 254. All day long we can do that. But as soon as we get above base 10, what happens? Yeah, now we get letters, right? Now we might luck out. I can start with my current value 172. I can say, give that to me in base 16. I bet you that guy is supposed to be a C. 0 C1. I'm not sure if that's the case. I'd have to actually do the math for it, but at the very least, it seems plausible that this 12 is not, it should be one character, right? So that means we need to make sure that we have the ability to take what our remainder was before we tack it onto our answer. We need to convert that numeric remainder to its potential letter remainder. Now, we only have to do anything to it if it's a value that's greater than or equal to 10, right? So we can tell this really quickly. So we can say, if remainder is less than 10, then we'll go ahead and build up our answer the old way, right? We don't have to do any conversion. If my remainder is somewhere between 0 and 9, I don't have to do magic. I got the right value. We'll just go ahead and keep it. If I run this guy again, is my remainder literally never that in this one? That's fine. So if my remainder is less than 10, we're doing this thing. Otherwise, my remainder must be bigger than 10. And if it's bigger than 10, I need to convert it. So if I have the number 10, I want that to be an A. If I have the number of 11, I want that to be a B, so on and so forth. How would you do that knowing what you know right now?
Which function are we currently working?
Well, I'm not sure it matters for this particular question, but I mean, we're in the middle of well, we're not even in a function right now. We're in the middle of our hard-coded initial value for converting this guy to its base equivalent. So right now we're converting 172 from decimal to hexadecimal. So if I have the number 10 as my remainder, how do I turn 10 into an A? If I have a 13 as a remainder, how do I turn 13 into a D? Any suggestions? Go ahead.
The ASCII method again.
So we can do ASCII math. Okay, geeky, fun. Probably actually faster, but probably not what we'd want to put in front of a bunch of other people. I'll give you a hint. We've done this before.
I think mine is better.
I actually kind of agree, but did I mess up my alphabet? A, B, C, D, E. All right, so, and we'll call this guy map because that's what we called him before. Doesn't matter. So that's our whole alphabet, including the digits. Where does this, what position in this string does this 0 live? Position 0. What position in this string does this 8 live? Position 8. What position in this string does this A live? Bucket 10. So instead of this question right here, and instead of converting my remainder into a string, can't I say map at bucket remainder? If remainder is some value, we're dealing with base 16 right now. If remainder is some value between 0 and 15, can't I just say, give me the character equivalent of that remainder? Even if it's a number, right? If it's a 4, so say, give me the character equivalent to a 4. Go to bucket 4 in map, pull out what's there. It's the char 4. Perfect. Don't even need to convert it to a string. You just concatenate that right away. All right. I have some extra crap down here. All right, so there's our answer there. A, C. And we are doing our reverse string because if we didn't do the reverse string, we would have gotten C, A. Which is almost the right answer, but you read it from top down instead of bottom up. All right, so now we have something that I can put in any base. Here, we'll do base 31. 172 in base 31. There's my answer, 5H. We wrote the algorithm, we know it works, let's just trust it. All right, so we have generic code right now that as long as we give it an initial value and that's in decimal and the base we want to convert it to, it will give us the rest of it as a string. The answer is a string. So that means I'm going to take everything below those things. I'll keep the print answer for right now, but we're going to turn it into a return. Now let me go back to our other program here. So here's our decimal to base. And well, here, I'll see here in a second. All right, so here's that code we wrote. It's operating on a variable called initial value, and it's operating on a variable called base. So now this code should work as is, except for right now, it prints the result. We want it to return the result. So instead of printing answer, we're going to say return answer. So now I have a function called decimal to base, just like I had a function called base to decimal. So if I come down here and I say base to decimal BAD 16, I get the answer. I print out the answer. And then I say the answer is equal to decimal to base of the answer that's currently in base 16. Well, I want to convert it to base 16. I should get BAD out of that. Should reverse what we just did. So we should have 2989. Oh, because my function reverse string I left over in Colab. Remember we wrote this guy up here? So we gotta bring this dude with us for the moment. Put that right there. We'll minimize that guy. We'll minimize that guy. We'll take some of these extra spaces out. And since we've been looking at this for a little bit, we can go ahead and minimize that guy. Just so it looks a little less intimidating. All right, so there's all my functions we wrote up here with them minimized so we don't see all the ugly code. And then down here, we're just calling them. We're going to say convert BAD from base 16, give me the decimal version of it. That's going to come into answer. We'll print that out. So now we have it returned the answer. We're then choosing to print what was returned. Then we're going to say, well, let's go ahead and throw our answer, which is now a decimal number. Let's throw that into our new function, decimalToBase, and say, go ahead and give me this decimal number in base 16. And then we'll print that result because decimalToBase returns our answer. We're going to go ahead and store it in this variable. So we are overwriting our own answer. If we wanted to keep them separate, if I wanted to have both answers, I could have called this guy decimal val. And I could call this guy hex val, something like that. And then we would have printed out decimal val and hex val here. So if I go run this guy, oh, where's this guy's called decimal val. So there's my 2989 and there's my BAD. They reverse each other. Okay, and actually, an interesting thing we just saw here. I'm going to go ahead and leave the answer in. So we know we have a syntax issue, right? Now remember, Python is an interpreted language. If we were working in a language like C, C++, Java, C#, Objective-C, or Swift, this would give us an error as soon as we hit the play button. It would compile it and say, the variable the answer is not part of this scope. I've never heard of it because it's not defined in here anywhere, right? We'll talk about variable scope in more detail, but at the very least in the neighborhood we're looking at right here, we don't see that variable being defined. I'm just randomly using it for the very first time right here, left over from what I was doing on the other screen. All right. But watch what happens here. In a compiled language, it would immediately give us an error. If I run this guy, notice that I started getting results because an interpreted language does it during runtime. It didn't slam into the problem until the program was almost done running. So you had all the outputs up to that point. Caveat, neither good or bad, but a thing. Questions, comments, concerns, bribes? All right, I will see everybody on Tuesday, whatever the homework is over the weekend. Like I said, I think I have access to everybody's collab now, so I will see you then.
What?
Thank you.